Ladies and gentlemen, please welcome Kit Colbert.
All right. Thank you, guys. So the topic of this talk is all about containers. Right? We've talked about a bit about this in the keynotes over the last 2 days. And so what we'd like to do here is take the opportunity to really dive in and give you more of background on containers, as well as how we're looking at it from a VMware perspective, what we're doing about it, as well as how some of our key partners, Google and Pivotal, are also approaching containers. And in the end, what we're all doing is working together to help customers run these new types of applications in production environments. And so the point I want to make at the beginning is that this is a very rapidly evolving space. Docker itself has only been around for, I don't know what it is, 18 months now, give or take. And so things are changing very rapidly. There's all sorts of new entrants in the market, all sorts of different players coming in and going out. And so it's one of those things that all of us, whether it's VMware, our partners, the industry, all of you as our customers, we're all on this journey together. And so as I said before, if you take nothing else away from this talk, I think the main thing to keep in mind is that we at VMware are very much committed to helping you run your applications in production, whatever form or shape those applications take. We have containers. We've talked about how a couple of years ago we focused on big data and Hadoop. And there's going to be the next thing and the next thing, right? So we're committed to helping you do that. OK, so let's dive in here. Before we dive in, actually, just a really quick bit about the agenda. So what I wanted to do first, because some of you may not be familiar with container technology, you may not know much about it, so I wanted to give a little bit of background there and talk about what they are, where they came from, and what's happening in that space. And then start talking about how we think about it in terms of infrastructure and then management, and then start diving into what this new third platform application stack looks like. And we'll finish up with a summary. OK, so the context. So as Ben was saying earlier today, containers have been around for many years. And this is not necessarily a new technology. But the key concept here is that you're essentially doing virtualization at the OS level. Right? That's conceptually what it is. Just like today VMware does it at the x86 hardware interface, what you're doing with containers is essentially producing isolation at the OS level. So here you can launch a container, and then you can launch an arbitrary set of processes within that container, just like we have today with x86 virtualization. Now, a couple of points. Let me build this thing out. Whoops. Can we go back one slide, please? Thank you. So this is OS-level isolation. And so one of the key points here is that the notion of a container is not actually built into the Linux kernel. So what's happened is that Google has really been at the forefront of this over many years, taking individual Linux subsystems and creating isolation properties within those. And then what you have is actually user-level components like LXC or libcontainer, what have you, LMCTF from Google, basically orchestrating all these kernel-level systems, subsystems, to produce what we consider to be a container, which is isolation across many different areas of Linux. As I said, these things, we've had Solaris zones, FreeBSD jails, OpenVZ. This stuff's been happening for quite a while. And Google's, of course, been a huge proponent of that for many years as well, like driving a lot of that in there. So one of the big reasons for doing this, and this is something that Craig will talk about later, is this notion of reproducibility and management at scale. You can create isolation between your processes, which really means you get a reproducible environment that you can deploy that, whatever it is, application many different times. Now, this is great, and it's something that has been around for quite some time, but no one really, in general, glommed onto it, right? It's one of those things that was there, but we didn't see widespread interest or really embracing of it until Docker came along. So what exactly is Docker? So the way Docker thinks about it is to take a look at the problem that we have today. We have all these different stacks, all this complexity in terms of middleware, in terms of the applications you want, different libraries you have to connect to, and so forth. And then you multiply that by the complexity on the infrastructure side, all the different types of operating systems, public cloud, bare metal, different use cases, these sorts of things. And so what you get is this kind of Cartesian product of possibilities, which is just really hard to manage, right? How do you kind of deal with all that diversity and complexity there? And so their approach to it was very much, conceptually, this container model, right? And so the interesting thing here is that they're not focused so much on runtime containerization as they are on packaging of a container, which means that just like we think of shipping containers, right, we can move these things seamlessly. So one of the interesting pieces here is that when you get this container type of concept, it separates out the responsibilities of developers and of the operations team. Developers are essentially responsible for everything inside the container. They figure out how to package it in there. The ops team then takes that container and runs it wherever they need to. And so you get this nice, clean abstraction level between the two sides. I think that sort of simplicity and the separation of concerns is really what's driving a lot of the interest here, is it just makes it easier to reproducibly deploy these things wherever you see fit. And again, you can think of it with the shipping container mentality or example, right? That the shipping container company, they don't know what's inside those containers. They just take them wherever the person says to go, right? And so it's the person inside of there that can manage that thing. And they don't know what routes the shipping container companies use, et cetera, et cetera. So you get this kind of separation of concerns, which is exactly what we're going for here. So the good news is that this notion of containerization fits really well into this developing DevOps lifecycle. And the notion here is that as you move between dev tests, user acceptance tests, integration tests, finally out to production, you might have staging in there somewhere. Wow, this video just keeps on playing, doesn't it? The point is that you get reproducibility across the way. It used to be one of those things where it's a big thing to set it up, move it from staging to production or from dev test to staging. The problem is that in each one of those environments is different. You have different subsystems running, different hardware maybe, different things on the operations side, different management tools, whatever it is. And so each of those differences had to be accounted for. But now you get this nice, simple way, putting things in that container, and that container can just be like a shipping container, move between these different environments. And so you get more of that consistency. Oops, let's build that out. OK. And so as I said before, Docker is that shipping container. And so I think the other really big aspect of Docker that I haven't talked about yet is this notion of the public registry. And so the point here is that as you move between these different pieces of DevOps or what have you, you need something common between all those. And that's kind of what this notion of the registry is. It's this common place where you can put things and then download them from wherever you end up being. And so Docker's done a lot of things kind of on the lower levels just to make that fit in so seamlessly with the developer workflow. So it makes it really easy to get started. You can take advantage of a container somebody else has created, download that thing, and start building off of it immediately. It just allows you to get up and running really, really quickly. So they plugged in really nicely with that dev workflow and then have that registry there so that the environment the developer creates on their dev box can look very similar inside that container to something in production. Makes it really nice. As I said before, it also separates those concerns so developers figure out what goes into the container and make sure that works. And ops figures out how to run that container and make sure that part works. Now, let's talk about this notion of second platform versus third platform applications. So you may have heard it, I think, in the keynote today, we talked about traditional versus cloud native. Same terms, right? So second platform apps are characterized by the client-server era. So these are things that are typically on-premise, again, the client-server sort of architecture. Usually they are quite stateful. They scale up rather than scaling out. So they're kind of heavyweight in that sense. They love to have, they don't have necessarily resiliency built in. They actually rely on the infrastructure or other things to provide resiliency. And they're kind of human-driven in terms of management and so forth. And so on the third platform, we're moving into the mobile cloud era, right? And so third platform apps are re-architected to be much lightweight and smaller rather than sort of big monolithic application architecture. They have a bunch of tiny things that scale out and all work together to create an application, to create some set of functionality. Now, what happens is a lot of that, they don't rely on necessarily any hardware, resiliency, availability, any of these other concerns, right? A lot of times that's built into the app. Now, this isn't universally true, but for many of these application architectures, it can be. And a big point about DevOps as well, in the third platform stack, is that it's very API-driven, right? As long as everything has an API, you can connect, you can automate it, and that's what we're driving on that third platform side. So I think the big challenge here is, when we're thinking about it from an IT perspective, is do you need to create a third silo here? And that's exactly what the arguments you're seeing in the media, in the blogosphere, on Twitter, et cetera, is about. We kind of have these second platform apps. We know how to do them. People standardize on the software-defined data center for them. But then you see these third platform apps, and people start scratching their head and saying, well, wait a sec. Is this something totally different that I need to create a new silo for? Or can I standardize it on my existing infrastructure? And that's exactly the question that we'll talk about today. So that is this question, right? That when you look at it from 1,000 or maybe 100,000 foot view, you kind of see those VMs on one side, you see, okay, these new container things on the other side, and you kind of think of them as separate, right? Kind of oil and water. Again, that's the conception that if you look out in the blogosphere, these are the kind of things that you see, that mental model, right? But if you dig into it and think about it a bit, you say, okay, well, yeah, there's these two things, but you know what? They both need management. They got to run somewhere. They need infrastructure. What are they going to run on? So what are you going to run these containers on? And so the question when you start looking at it is, does it make sense to create another silo? Right? You get the traditional higher CapEx, higher OpEx from all that duplication of effort, different tools, different technologies, et cetera. So I think what we see the value and really the opportunity here is, can we unify this, both on the infrastructure side and the management side? So that, yeah, you have VMs, applications running in VMs. You may have apps running inside of containers. But the point is that you can consistently manage and run those things on a consistent infrastructure. I think that's the opportunity that we really see. And we'll talk a little bit about what that looks like. So in particular, we have, this is kind of a summary of some of the things we'll talk about. But what we can do is bring to bear all the benefits we talked about with virtualization, both on the compute side, the network side, the storage side, in order to provide that unified fabric. On the management side, we'll talk about all the consistency in terms of operations management, provisioning and lifecycle management, so on and so forth. And then we'll also dive into this containers box, that sort of third platform stack. Because in many ways, that stack is very different from the traditional sort of second platform, three-tier architecture. Right? There's some differences there. And again, this space is moving really quickly, so we'll kind of give you a snapshot of where we are today, and also talk about how we look at it going forward. So that's kind of a bit of a map of what's going to come. So let's start off talking about the infrastructure side here. So the first point I want to make is that a lot of people talk about VMs or containers. And we talked about at the keynotes this morning and yesterday, this power of and, right? And we really think that's exactly true for VMs and containers in terms of their isolation properties. When you think about VMs, you think about hardware-level isolation. And this is really, the focus on virtual machines has been for security and multi-tenancy. This is something that's been built in from the ground up. These VMs have to act and look and everything behave like separate physical machines. They happen to be a VM, but for every intent and purpose from the inside, they look like separate physical machines. Whereas with containers, what they're looking at is more of an OS-level isolation. They're not looking at separate physical machines. They're just trying to get that isolation between processes. So you look at what we're doing on the VM side. We've driven a lot of innovation with Intel and have actually offloaded a lot of the virtualization onto the hardware. Right? This actually makes it even more secure because it means we have to deal with less system calls. The surface area of attack is very small. There's only maybe 30 or 40 calls that are made to the hypervisor from the hardware. Whereas with OS, what you're dealing with Linux, which was built to be quite an open system where all processes can communicate and see each other, and trying to close that down sort of after the fact, right? Which makes it harder. There's a lot more system calls to deal with. So traditionally, what we hear from customers when we talk to people about it is that they look at VMs for security and multi-tenancy, and that's what they're great for. And containers are great for reproducibility. This is the thing I talked about earlier. When you have an application, you want to run that application in the same environment every time. And that's what containers allow you to do, because they can take that Linux system and actually carve it up so that from the application's point of view, everything looks the same. The libraries, any other sort of binaries they might use, configuration files, et cetera, it all looks identical, irrespective of where you're running them, on your test dev box or in production. So we think that putting these things together is actually the best of both worlds. They actually do want to layer them. Now, you might say, okay, well, that's great, Kit. Of course, VMware is going to say that, but then you might say, well, okay, hold on a sec. But isn't there going to be performance overhead? I mean, aren't these VMs, they get painted as being fat and slow and everything, right? So let's take a look at that. So first of all, I don't think that's true at all. I think, as I said, we've been driving tremendous innovation with our hardware partners, offloading a lot of the virtualization we do into the hardware. So there's very little overhead. I mean, for most workloads today, we're talking about single digits, right, percent difference. And sometimes we've actually shown that workloads running inside vSphere are actually faster than those on bare metal due to some of our really good scheduling in terms of NUMA and other things. So a VM can be started in less than a second. It's very quick, right? The thing that actually takes the longest is, of course, the OS. The OS has to boot. That can take seconds or minutes, depending on that OS. So there's a couple of things we're doing, right? We're continuing to innovate on the. So first of all, I said by itself, I don't think VMs are heavy, but we always challenge ourselves to do better. And so Project Fargo is one example of that, right? We've sort of talked about this a number of times in the context of end-user computing, as well here in the context of containers. So with Fargo, what we can do is actually fork that virtual machine. And so we can have a duplicate virtual machine up and running very, very quickly, less than a second. The OS is already fully running and so forth. So you get rid of that OS boot time. But we're also seeing as the ecosystem coming in to make OSs thinner and easier to run. Things like CoreOS or Project Atomic from Red Hat. We're seeing a lot of this stuff coming into the industry here in the ecosystem. So in general, people will talk about virtual machines as being heavyweight or whatever. But in my view, if you look at the facts, you actually read the data and so forth, it's not true. Now, the other thing I will say is that sometimes you see these reports from people comparing sort of VMs and containers. And you really got to dig in. What are they actually comparing? Are they comparing apples to apples or apples to oranges? Many times you find they're not comparing the right two things. And so the tests don't really make any sense. So I wanted to hit on that point because I think it's really important that this kind of thing gets lost in a lot of the other noise. OK, so let's move on to networking. We talked about compute. Let's talk about networking. So networking, I think, is actually extraordinarily important as we look at container technologies. It's a big challenge to figure out how to do routing, how to do IP addressing, how to figure out how to get two containers to talk to each other. And there's all sorts of different solutions out there for this, but a lot of them happen at the L7, the application layer. And it can just be quite challenging and impose scalability limitations when you try to do it that way. And so one of the things that we found is that leveraging NSX, we can actually create these L2, L3 networks and make it totally transparent to the application. So this is something that makes the application, the developers' lives so much easier because they don't have to think about these sorts of problems. They can just write their app, have the app get a network dynamically created for it, and it can talk to all the other pieces of that application. Actually, just as an aside there, so what you generally find is you find many containers as part of an app. Many containers usually form into a service or a microservice. Those microservices are then composed to comprise an application itself. So you have different levels of this stuff. And so as you can see, the networking can get quite complex there. But if you can kind of separate that out, again, get the right abstraction there that NSX provides, then you have something really special and makes it much simpler. And of course, you get the built-in security of NSX, right? Again, just the same way that compute virtualization gives you that separate physical machine isolation, you get the exact same thing with NSX for the network. Storage is another area where I think we really need to think about it more in terms of how do we virtualize that storage away. Now, what you find today when you're looking at many container technologies is that the application is actually really tied to the storage in terms of when you provision compute and storage, they're typically provisioned together. A lot of times, the app will use the local storage of the host or virtual machine that it's running on. And I think one of the powerful things that we've done here at VMware is to disaggregate the compute from the storage so you can scale each of these independently. So think about this, right? This very simple example. I've got to provision my container, my microservice, whatever it is, a set of containers. And I need to get persistent storage for that. Now, as you guys know, these containers, they're different from your SAP or Oracle apps where these things might get taken down for whatever reason and restarted somewhere else. So how is it that you can deliver the storage to that container wherever it goes? Right? That's a hard problem. You can't just have the storage be on the local host because you have to restart that container on the same host every time, which reduces its availability. Since if the host is down, its data is gone, and now that container can't run. So that's what I'm talking about by disaggregation, right? Irrespective of what compute node that container goes to, you can always deliver the storage there. This is exactly what we're doing in virtual SAN, right, with vVol. It's these sort of technologies that allow you to map the storage dynamically wherever that container happens to be. So we think there's an incredible amount of opportunity here to, again, simplify the life of both the developer and the operations team in terms of this container model. So when we put these all together, it really goes back, it's the simple value prop of VMware, right? We got our start from sharing infrastructure, from consolidation. And we think that applies here as well. A few years ago when we started talking about big data and Hadoop, the same sort of questions came up. It's like, hey, does this stuff work in, does Hadoop work on top of vSphere? Why should we do it there? Why shouldn't we create our own silo? But of course, the point is that the whole point of virtualization is that you can do all this stuff dynamically, right? As workloads change, you don't need separate physical infrastructures. You can combine that together to make the best use of what you already have. That's the exact same thing we think we can do with containers. It's another workload, right? VMs are very lightweight. You can move these things around. You can dynamically provision them. It doesn't matter where it starts up. You can assign the storage there. You can dynamically create the network. I mean, think of all that complexity there and the rigidity. This is the stuff we've been working to get away from. We've been doing it for all apps. So are containers really that different that it necessitates a whole other architecture with a whole other operational model? So we don't think so. We think that the investments that you guys have done into your traditional or Platform 2 apps make perfect sense to extend to containers. The exact same problems are there. The same problems around getting access to the network and making that simple, to storage, lightweight compute. And in the end, getting the best value out of your infrastructure, right? So that's, I think, the big takeaway here, is that we see, again, containers being very complementary to VMs because containers are about packaging and delivering that application. And then VMs are the infrastructure on which you can run them securely. The final piece about this is, of course, hybrid. And we talk about that with vCloud Air and how you can seamlessly move from on-prem into the cloud. Another big point here is that you can do that for containers as well. And so it's not just, by the way, I think when a lot of people talk about containers, they focus just on, OK, well, the container itself is lighter weight than a VM, and we get into all that stuff. But the point is, when you think about bigger, you think about this operational model. Like, how do you get the network to that container? How do you get the storage to that container? How do you ensure it's secure from a multi-tenant perspective? That whole operational model will follow you wherever you go, right? So if you want to have an on-prem container solution and one in the cloud, well, you have to replicate all those operational concerns. And so that's exactly what the hybrid cloud's all about. It's not just about the basic infrastructure. It's about the operational model. And so we think that the hybridity, making that so simple to go back and forth, making that consistent across those two sides is really important for traditional apps and for these new third platform apps. OK, so that was a quick dive into the infrastructure side. Now let's talk about management. So we're back again to the same life cycle. Right? And just like we had to provide the infrastructure to move between these different phases of the life cycle, we also need to think about how do you actually manage this life cycle. So let me build this thing out here. OK, so on the second platform side, as I said, you find a lot of the traditional three-tier architectures. Third platform is a lot more complex. Well, in some ways more complex. In terms of management, it certainly can be. Because what you find is not the simple three-tier architecture. You actually find an explosion of individual containers to manage. And I think Ben talked about this morning in his keynote. He's like, you don't manage individual processes on a host, individual, whatever they are, background services. Instead, you think about the host or the app or whatever it is in a bigger context. And that's the same thing here. You take these containers, you compose them together to create a microservice. You take the microservice and compose those together to create an application. And so it means that you need to apply the same sort of management that you have for second platform apps, but do it at scale for these third platform apps. So let's see how that's going to work. So I think the first thing to think about is how do you get a clean separation between infrastructure and apps? Now, why do you want that? Well, you want that, as I said before, that we're really trying to solve for two different parts here. We're trying to solve on the IT side for security, compliance, multi-tenancy, the operation model, all these different parts. On the dev side, they want to run as fast as possible, right? They don't want red tape. They want to be able to click a button and get it done. That's exactly why they're going to these public cloud vendors, because they can do that, the one-click access. So we don't want to slow devs down, but at the same time, we want to get all the requirements of IT met. And so we need to do that from an architecture standpoint, which means that we want to think about how do we manage the infrastructure, and how do we manage the applications. And we do those in some ways separately, but then they can come together in the right ways. And so the infrastructure management will probably be a little bit heavier weight because you're going in a multi-tenant scenario. You want to make sure you have multi-tenant security there. App access will usually be within a tenant, the actual developer possibly managing that. So that's going to be lighter weight, fast, API-driven. So we look at vCloud Automation Center, right? So this is a great tool for managing the infrastructure. And I want to emphasize here the infrastructure. So we saw that demo this morning that Ben and Raghu did. And what it showed was us actually provisioning a Kubernetes cluster from vCloud Automation Center. What it didn't show was what was really happening inside of there, what the app was or how the developer was really using it. I mean, it kind of touched on it, but not too much. So the point here is that developers will have to come into this vCloud Automation Center self-service window to get the infrastructure they need at the click of a button. And once they do that, they've created essentially their own sandbox where they can go off and run and do what they see fit inside of there. So IT gets, again, that security and compliance around the sandbox, around that infrastructure the developer's provisioning. And then the developer can go inside of there and play and do whatever he or she wants. So in order to do that, we need a few pieces. We need self-service, the ability for them to come in and click something, and to get that provision for them immediately if it's approved. The second piece is governance. So just like towns or cities are governed, data centers have to be governed as well. And this is something that you guys all implement today, some sort of governance. It may not be explicit, but there is governance there. There are rules you have to follow, right? And so what vCloud Automation Center is about is really making those rules explicit and putting them into programmatic policy so that it can execute it automatically without humans necessarily being in the loop. The last piece is automation. And that's really a key part of all this, right? Being able to click that button, go through the governance engine, and if it's approved, then automate the delivery of that infrastructure, that virtual infrastructure, to the developer. So we see vCloud Automation Center being really important here for the infrastructure, but not necessarily for the app itself. I mean, you could do it that way, but what we're going to see is that there's actually alternatives for managing that application, and we'll talk about that in the third platform section in a minute. So the other piece is not, so that first piece was kind of lifecycle provisioning management. This piece is really about operations. Once it's provisioned, how are you going to manage it? And I think this is an opportunity to, again, kind of collapse the stack, if you will, to be able to see across the stack. You get there into the infrastructure as well as into the visibility into the application to see end-to-end what's happening. And so this gives you things like performance monitoring, capacity management, log management, so on and so forth. And so the tools we have today, things like vCenter Manager, Operations Manager, and Log Insight and so forth. These are products that are heterogeneous by nature. They can span different types of infrastructures, and they can get inside the application. So this is one where you actually do want full visibility, but the provisioning and lifecycle management is probably going to be separated between the infrastructure and the app. OK, so again, a quick whirlwind through that section. So now what I want to do is kind of dive in on this container piece, right, and focus on what's going on in there. So we're back to the same slide. We've shown it a few times. But I want to talk about a different aspect of second versus third platform apps. It's kind of a fundamental distinction that I haven't raised yet. So people use this metaphor of pets and cattle for these types of apps, right? Second platform apps are like your pets. You give them names. There's only a few of them. You hug them. You kiss them. If they get sick, you take them to the vet because SAP Oracle can't go down, right? It's got to stay up and running. Third platform apps are more like cattle. There's a lot of them. They don't really have any names. There's just a bunch. They all kind of look the same. If one of them gets sick, it's best to get that one away from the others because it might infect them or do something bad. So it's a very different mentality about how you manage, right? The pets, you want to make sure they stay up and running. The cattle is more like, let's get rid of the ones that are sick, but we don't try to fix those. We just let those ones go. And so when you start thinking about that, it means that the way you manage it will change as well. And so as a part of that, the architecture itself, the infrastructure stack, changes a little bit. So as we've been exploring this, I haven't seen anything that kind of puts together the full view of the stack for third platform apps. So this is something we're trying, and perfectly open to being wrong about it or whatever, refining this over time. But this is the first crack at it, right? And so the idea here is that we have the developer side stack, and we have the production side stack. So on the production side stack, we have, again, our rock-solid infrastructure layer. We then have usually some sort of container-optimized Linux run on top of that. We then have the container packaging, the actual thing that delivers that application inside of the container. But delivering just one container is fine, but you really need to scale up, right? And so that what we're seeing is these cluster schedulers come in that can actually, given a pool of infrastructure, and you got one container you want to provision, it'll figure out which one to provision it on, and then manage that container or set of containers over their lifetime, adding more, removing more as a need arises. But then at some point, as I talked about at the very beginning, this is not really about containers per se, right? This is about apps. We need to run apps. And so somewhere you have to have a translation level between the containers and the app. So you may have these different containers. They may have different microservices that they build into. But then at some point, you need to define what this app is and what it's doing and what that app needs in terms of infrastructure requirements, how to compose together different container technologies, so on and so forth. So you have to have something at that level. The final level is then the management pieces that we talked about. So let's dive into each side here. We'll start with the developer side. So on the developer side, I just want to give you a flavor for what's out there. As I said, this is a very rich ecosystem. It's evolving constantly. There's constantly new players. I mean, some of these people I'll mention are literally just like weeks old. They got like 2 or 3 people working at their company. So it's, again, very early days for much of this space. On the developer tool side, one of the biggest ones in this space is HashiCorp's Vagrant. HashiCorp is a company of like literally 3 people. But they've been turning out lots of code. They're great stuff. They have 1 million downloads of Vagrant. There's a bunch of other things in here around Jenkins and GitHub, some of these more well-known ones. There's much more there. There's just a few examples, right? But these are the things that developers are starting to embrace to help move through that continuous integration and delivery process. On the container packaging, really Docker is the main one and kind of the only one in that space. There's not a close second, really. And this is exactly their popularity, because they've really nailed that container packaging problem out to that container repository in the cloud. On the Linux side, there's, of course, many different alternatives. Docker has one, Red Hat, Ubuntu. Ubuntu is probably one of the most popular for running. And then a lot of people actually do use Fusion and Workstation, our products. As a matter of fact, HashiCorp's Vagrant has those built in and leverages them themselves. So let's look on the other side. It gets a bit more interesting on the production side here. So again, this is just a sampling. There's so many of these players, it's crazy, right? But I just wanted to list a few of them. So what you see is a slightly different variant of Linux here, where instead of it being the normal variants of Linux you're used to, it's these container-optimized ones. CoreOS might have the most mindshare here, being very, very lightweight, very small Linux package, gets the basic stuff done to allow you to run containers there. Again, on the container packaging side, it's Docker. They have the mindshare. The industry is the ecosystem's coalescing around them. On the cluster scheduler level, there's a lot of innovation happening here. There's Kubernetes from Google. They made a big splash when they released this a couple of months ago, getting a lot of mind share there. Docker is starting to get into this area as well with something called LibSwarm, which is really more of an API than an actual container cluster scheduler itself. Mesos is another big one. This is one through the Apache Foundation, and it's open source. A lot of people are using it. Fleet is a new one from CoreOS. There's many, many others. Again, there's a lot of options here. On the app definition side, we're also seeing a lot of innovation happening. And so, Pivotal Cloud Foundry has been doing this for many years, sort of enterprise tested and proven. There's some new entrants from this company called Orchard, which actually just got bought by Docker a few weeks ago, a product called Fig. HashiCorp, who I mentioned earlier with Vagrant, also has Terraform. And there's Shipyard. There's many others, right? So again, this is a space, and you in IT don't necessarily need to know the ins and outs of all these, but I think it's good for you to have some idea of what these things are and kind of how they plug in, right? So I just wanted to give you a really quick overview there. But what you'll find is it's kind of the alphabet soup, all sorts of strange names left and right. But there's a lot of innovation happening here, so we really need to keep our eye on it and embrace these things, because in the end, this is what you'll be using in your enterprise to take these applications from the dev side out to production. Okay, now with that, what I'd like to do is give Craig from Google a little bit, as well as James from Pivotal, a little bit of time to really talk about each of their perspectives on the third platform. These are both teams and companies that have been invested in the third platform container space for many, many years and have a tremendous amount of innovation. So bring up Craig from Google. There's a clicker.
Alrighty, so as you probably know, Google's kind of big into containers, and there's a very good reason for that. If we look back a decade ago where we were, things were kind of desperate. It was really hard to build and manage applications at internet scale, hyperscale. We only had a few production services, and it took every ounce of will to maintain those and keep them up. And Linux application containers really changed the game for us, and they did a couple of things that are really important. The first is that they enabled, as Kit said, precisely as he said, the separation between the infrastructure management and the application management. And this wasn't just about containers, it was about containers and the ability to actively manage and schedule those containers into a fleet. So we moved away from a world where all of our applications were tied into a specific piece of, into an operating system image and into a specific piece of infrastructure, to a world where we could think about this vast fleet of machines, and then we could schedule into those machines and use these as fungible resources. But beyond just you could actually get a lot of that with modern virtualization technologies. They weren't there when we did it, but today some of that exists. But the other thing that containers gave us, which is really important, is an incredible boost in efficiency. With container technologies, we're able to schedule workloads next to each other such that a high-priority workload is never preempted by a low-priority workload, but that they're sharing the same basic set of resources. So we moved to a world where we had this decoupled world. We had a very small team that could manage these vast amounts of infrastructure, and our developers could just focus on running their applications. And in getting there, we learned a few things. So over the last decade, we've learned a few things. I'm just going to go through 2 of those quickly, just to give you a flavor for where we're going with some of these technologies. The first thing we learned was that every time, declarative management trumps imperative management. Being able to give your developers a framework where they can say, take this and run it for me, rather than run this on this machine, creates much better outcomes. It gives an opportunity where they can just focus on their code, and you can get systems like the system we internally call Borg, which is really good at running things. We've put a lot of effort into making a system that uses deep machine intelligence and constantly watches these applications and workloads and makes very informed and very well-balanced decisions on how to run it. And so that creates incredible efficiencies, but it also comes at a cost, which is you're not running it yourself, so you don't often know exactly what's happening. And one of the things you'll discover with some of these container technologies is you really do need both a cluster manager and a set of technologies that let you get a lot of introspectability and insight into what's actually happening with your applications so that if something does go wrong, you can address it. The second thing that we learned is that it turns out if you make it really easy to build production systems, make it easy for engineers to actually build and deploy things into production, they're going to build and deploy things into production. We actually saw this incredible spike, a huge step function in the number of production services we're able to run. For our business, it was amazing. We were able to diversify and actually start focusing on building out a whole broad array of businesses and do that much more efficiently. But again, it comes with its own set of problems. Governance becomes really interesting. It becomes a really tricky thing. You need to be able to find your services. You need to know what versions the services are running. You need to be able to define policy and manage policy against them. So again, you're going to need a cluster manager. And you're going to need a cluster manager that's going to let you govern and manage and take care of very large numbers of production services. So we created Kubernetes. Forgive the name. There's a long story behind that, but it is an open source project that's owned by the community and was inspired originally by the way that we run our own cluster management systems. We're very pleased to welcome VMware to the Kubernetes ecosystem. They're doing some amazing work to not only extend the reach of Kubernetes so that all of the VMware enterprise customers can benefit from it, but they're also giving back to the community and doing deep integration with things like Open vShift and making sure that the Kubernetes base itself is a very robust and strong platform. And what Kubernetes does is it brings this Google-style cluster management to your container universe. And it has 3 properties that I think are really important. The first is it's lightweight. We really wanted something that you could easily pick up, understand, deploy. And then you need to be able to customize it, so it's modular. You can easily extend it and drop in whatever you want, so it can go anywhere. And then it's portable. Like, your cluster manager is no good if it can't run containers where your containers can go. And Docker's created this incredibly portable packaging format. We had to produce a cluster manager that could go where those Docker containers can go. So Kubernetes has all of these properties, and it really is owned by the community. And how do VMs fit into this? Now, Kit already did a pretty good job, so I don't want to necessarily completely go over stuff that he's already covered, but I think it is worth just mentioning that inside Google, we are very fastidious about security. We do see some advantages that containers offer to providing isolation, even in the security domain. But when we want to run 2 untrusted actors' code together, and that code is both untrusted and needs to be unconstrained, we really believe that the VM boundary is the best and only way to achieve the level of isolation we're looking for. Now, VMware spent the last 15 years producing an incredibly robust technology. And the nice thing about the VM is that that surface area is pretty small. VMs produce idealized infrastructure, idealized hardware, whereas containers provide an idealized operating system. Now, it turns out that infrastructure layer is a much smaller and much more defensible area. So whenever we are putting together a solution that requires multi-tenant capabilities, we use VMs. But what we do is we stitch together those VMs using this cluster manager so that you have this mini Google cell that's running in VMs that provision the basic infrastructure, provision the basic hosts, and then the cluster manager can schedule many, many containers and get every ounce out of that physical infrastructure because it's running at a higher level of abstraction. It has much more insight into what's actually happening inside those virtual machines and what resources are being used by applications. So what's next for us? Kubernetes has already been amazingly adopted by the community, and we're really humbled by the amount of support it's got. We're very proud to welcome VMware to the family, and we will obviously be working to make it work everywhere. We're pretty portable and pretty mobile right now, but our mission is to continue that and make sure that it runs in every cloud environment, hybrid, public, you name it. The next big piece of this, obviously, is operationalization. It's a young platform. We've published a roadmap on our GitHub site. You can actually look at it and see where we're going. But we really want to focus on operationalization. And that's why, again, people like VMware and other partners like Red Hat and IBM are helping us operationalize this technology and making it accessible to mainstream enterprise or anyone who wants to use it. And then the final piece of this is, when we think about the development of microservices and these microservices-oriented architectures, it's not enough just to have a cluster manager that thinks about scheduling discrete containers into an environment. We also need to create a set of services so that you can start building distributed systems using these microservices. We aspire to make building something like Bigtable, our incredible distributed database, a CS 101 exercise by just really pushing a lot of intelligence and a lot of capabilities into the services framework. So you'll see a lot more from us, and we invite you to take a look at our GitHub site and look at the code. Thank you.
So that was great, and I just want to comment on a couple of points that Craig made there. I think I talked about it earlier, how we want to kind of separate out sort of the application management from the infrastructure management. I showed how vCloud Automation Center can really automate the self-service of infrastructure management. And you heard Craig talk about how Kubernetes comes from the other side down, from the app side into the VM. It knows what's going on in the VM. It knows what containers are running there. It can manage those containers and scale those things out. So that's really powerful, and it goes to show, again, how we can kind of combine these two great technologies to get you a better solution, right? Something really cool there. And it's great to be partnering with Google on Kubernetes, really driving that whole ecosystem forward. So now I'd like to invite up James Waters from Pivotal to talk about everything Pivotal's doing with their Pivotal CF, which is Cloud Foundry, something that started at VMware a few years ago, 5-6 years ago. Now Pivotal's taken it, embraced it, and is driving it out to enterprise deployments. James?
So I don't have an exhaustive deep dive into Pivotal CF, just a couple minutes here. So just wanted to highlight some things that we're looking at. And the real trend that we see, or the two defining things that are going on at a bigger level than just infrastructure, are really cloud and agile, are changing how people think about building new applications. And as Kit mentioned, one of the outcomes of this is they want to be able to move faster in individual teams on different kinds of applications at the same time. So monoliths have given way to something called microservices. So with Cloud Foundry, we really wanted to build a platform that would do end-to-end enterprise operations of these applications in a microservices format. And we use containers, but here was our to-do list. We really wanted to take away that old trouble ticket model that Kit quoted is actually one of the original engineers on Cloud Foundry wrote that write code, not trouble tickets. And when I talk to enterprises about this, is today you have a data center, and every piece of that data center is configured by humans. And so when you want to deploy software, there's this human intermediated process that you have to work through. And what we wanted to do with Pivotal CF is we wanted to transform that into a software factory. So we thought from the application down, how do we make a software factory out of your data center as one cohesive thing? So we wanted to also move between that week-long or month-long or even day-long deployment process to something that was really real-time. And I'll talk briefly about how containers help there. And we wanted to focus on ease of deployment, make it easier for developers to deploy things. But it was really even more important for us to reduce the cost of operating those applications after they were deployed, because that's the real impediment to doing new things, when people get afraid of deploying things because it might be too expensive. So a quick highlight, why do containers, why were those the perfect fit? So we were doing this back in 2010 and 11, already working on containers in a platform before it was cool. It was just a necessary step in our engineering process. And the reason is it takes all these operations down to seconds. So you want to deploy an app, it takes 20 seconds now, spin up the environment for it. You can scale it. You can reconfigure the networks that that app is allowed to talk to in seconds. That's something that people have been very interested in Cloud Foundry application security groups. And seconds to health management. So as Kit mentions, it's just like cattle. If something dies, it's restarted very rapidly. The second thing, though, and this is where Docker's really come along to help, is it introduces that new unit of currency where you can now push a Docker image to the platform to run. In addition, we started off with traditional like Java files, WAR files, etc., Ruby applications. So today you can push applications or Docker images to the platform. Another thing I want to highlight, and this is some good customer conversations at VMworld this week, we wanted to do this in a highly integrated way with VMware. So we didn't want to introduce yet another silo where you had to go operate a new kind of infrastructure to build a platform. And so we've got this installer that's actually Google Borg inspired. It's a very small world. That allows you to automatically integrate and start the platform and scale it on top of VMware using its APIs. So in that third platform style of DevOps, we use the VMware APIs to install, configure, and operate the platform. So you don't have to get a new set of infrastructure to do it. I thought this picture was funny. When you're doing containers, containers alone aren't enough. So if you just say, hey, I started a container, I have a container, I won. And that's not what enterprises want. And the enterprises I talk to, they really don't want their development teams out building net new platforms and stringing together things with spaghetti with containers and rewriting infrastructure. They really want to buy a cohesive platform that brings this all together in a standard way. And that's what Pivotal CF really is. So I'll go through this very fast because I want to show you a fun demo to cap this off with some live running code on top of that we've got for our next edition that's coming out. So these are the common services we bring to those containers and allow you to transform your data center into a software factory. By having all of this in one platform, that's really what it avoids you having to go between the network team, the load balancing team, the health restoration team, all these different teams, the deployment team, all that happens very naturally in one platform using Pivotal CF. And that really does transform the way people are able to deliver software in a lightweight way in this microservices fashion. So we have lots of deeper dives on this, and this is a slide I could spend 2 hours on. The nice thing is that because we came from VMware and we're supported by EMC at Pivotal, we've got this great, already huge base of enterprises using Cloud Foundry. These are folks just in June who came and spoke about their enterprise adoption of this. And a lot of these people are doing it on vSphere today, so they're already enjoying those benefits. And what I like to tell folks is this is not complicated. We can have a platform as a service based on containers running on your vSphere infrastructure in half an hour. Just give us access to the APIs and you'll have a platform. So with that, I'm going to show a quick demo. And what you're going to see here is Docker, which is the talk of the town at this VMworld. And we're going to take a Docker image, and this is our new beta edition of our cluster schedule that we actually have within Cloud Foundry. And what you see highlighted there are a number of virtual machines. So this could be VMware, any virtual machine, the API that you want to use. And they're going to push a Docker file to it. And what this demo is going to show is they're going to scale that application up to 300 container instances scheduled across those VMs. At that point, that'll take about 30 seconds to get to 300 instances. Now it's pushing it, and it's going to come up live. So the first thing you'll see is that it pushes the application, the system receives it, and you'll see the application running in just a second. So the system has received it, and now he's going to go hit the URL and check that the app is up and alive. But the fun part is you'll see all the common services now built into this application after it was deployed. The first is the dynamic routing. You saw that before on the other slide. So you're going to be able to immediately access the app, and I think we'll do it right here. So we'll check and make sure the app is running. And that whole process took, about 20, 30 seconds. Some of the typing on the command line took a little bit extra. So you now started an application in a container, put it behind a load balancer. It's live on the internet or live there. It's got these environment variables, so it's able to discover the data services it's supposed to be talking to. And you'll see now that it also has logging service, so you don't have to go wire that application to get logs out of it. That's all baked in. So you've really changed the abstraction layer from any single virtual machine. It's now been scheduled across this machines. You can see the little green dot in the top corner. That's where this one instance of the application is running. The next thing we want to do, though, is this app's a really popular mobile app. And so suddenly you need to scale it up because everyone's using it. And you don't want to have to go through a long infrastructure process. So in a declarative fashion, just as Google mentioned, you're going to issue one command which says, actually scale this to -300, go. Now what's going to happen now is our container manager is going to start what they call a distributed auction process. And it's going to schedule in a very even fashion across all these virtual machines that application to run. And you can see the logs just streaming out now. All these application instances are starting. And you'll see that's very even. They're making judicious use of every resource on those virtual machines, and all of those app instances are starting. And you'll start hitting refresh, and each instance is going to carry a tag number. So you'll see from 0 to 300 be started. You could not do this with just base virtual machine technology. It would take a little bit longer. Maybe with the new projects coming out, we could operate that fast. But this is one of the things that containers deliver you. So you have common logging service. You've scaled it up to 300. You've got other things that will be built in the app, all as services coming out of the app. The final thing we're going to do, though, is just to show that, again, it's about the operational benefits of treating it like cattle. We're going to go in and just kill 2 of those virtual machines. And the endpoint is not going to go down. And you're going to see it do a full re-auction and recovery, where it'll reallocate those container-based applications running on those virtual machines in real time for you. So give it a second to get the whole way up to 300. There it is. Let's kill 2 virtual machines. For this demo, we hacked it out in Amazon, but this also works on vSphere, of course. It was very easy to bang it on Amazon over the weekend. So we'll kill those 2 virtual machines without warning. And what will happen in about 1 second, you see they're disappeared from the top corner. And now it's going to realize that it needs to reschedule those containers across those virtual machines while keeping the app healthy. It's rescheduling right now. You can see the instances coming up. It's all rescheduled. And in seconds, the platform has healed itself. So when I talk to enterprises about this, they get really excited because they say, wow, my developers can now just push a container image or an app and it'll automatically start. They get logging right out of it, and the health management over time is exponentially easier than thinking about a single system where they have to keep it up. So that's just a little preview of what we're doing with containers and Pivotal CF, and thanks for having me, Kit.
Thanks, James. So that was really cool, right? It kind of showed you those containers in action, and all the different parts we've been talking about, the sort of second versus third platform differences, the sort of cattle mentality, the API drivenness of it all, the ability to rapidly start up many of them on demand, right? So very cool stuff. So a couple of points here on the summary. The first thing I wanted to say was that, we at VMware, we're in the same journey as all you guys, right? We're a company. We produce software, right? A lot of software. And so we have a software development process internally as well. And we are looking to embrace containers internally, right? So as a matter of fact, we have a team that produces the IT business management suite. They're based out in Israel. And they have embraced containers and are really driving that within their own group. So it's really cool because they actually leverage a number of things we talked about, Mesos, Fleet, etcd, Jenkins, and so forth. And they use both an on-prem vSphere SDDC as well as vCloud Air, and actually use those together to get their full development lifecycle. So that's really cool, right? And so as I said, this is not, this is something that's affecting all of us. And I said at the beginning, we're all in this together. We're all working through this, trying to figure out what this ecosystem is and where it's going. We're all doing that together. So just like we need to enable you, our customers, to be successful in provisioning and running your applications in production, so do we. Right? We ourselves as VMware. So we're finding tremendous value in these technologies, which is why, again, that's yet another reason to embrace them. So cool stuff there. So the final piece I wanted to talk about was just the notion of openness. This is something that I think we've hit on over the past couple of days. We talked about our OpenStack initiative. We talked about a lot of the partnerships we're doing in the container space with Google, Pivotal, Docker. And so we're very serious about this, right? We're very serious about enabling choice. And in the end, it's about running your apps. I think I said that before, right? Whatever form those apps take, however you find it best to run them, we'll be there to support you. That's what our focus is. So finally, in summary, I think I just talked about that first point there. And as I said, all these innovations we've been doing in the software-defined data center over all of these years, both in terms of infrastructure and in terms of management, we think are perfectly applicable to containers. And it's one of those things where we're not stopping. We're not sitting still. We're continuing to innovate. Talked about Project Fargo. We're doing a lot of stuff on the management side as well to really plug into that DevOps lifecycle. The final piece, as you heard from Google and from Pivotal, these are people who really know all about containers. They've been doing it for many years. They have a lot of experience running it themselves, helping enterprises with it. And so we want to work together to produce a solution that will enable you guys as our customers. So with that, I think, let's see, do we have time? Do we have time for Q&A? I don't know. Yes? I don't know. I'm not seeing any signs. Thumbs up, thumbs down? Yeah? OK, we have time. So we can take some questions here on the microphones.
Kit, first of all, great presentation. No questions, but one compliment. Between last week and this week, between your presentations, I don't know whether presentation has improved or I have improved, but I understand much better.
Thank you. Any other questions?
Actually, one comment, especially to the Pivotal team. So the thing is, you guys, made a really cool product, and I'll tell you because I'm actually from Apollo Education Group, and we started experimenting with it. It was so cool once I actually had the WAR file. For me, I had, we actually had an intern without much knowledge who actually was able to go drop it in 20 minutes. He was actually able to understand how the flow worked, and it was running. I mean, it's so cool. 20 minutes is all it took.
It's exciting. I mean, I think that's, it's a great proof point, right? Is that like, as you start to get this stuff up, you can see how easy it is that this re-architecture on the third platform just makes application development and deployment so much easier. And that's exactly, again, I keep hammering on this point, that's exactly why we're embracing this. We don't see this as a threat at all to VMware. We actually see this as an opportunity to help our customers do even better in terms of provisioning and delivering applications. You have a question?
Basically, is the goal to have like one VM per container and then using the VMware technology to just scale it out really fast as needed and using NSX around all the other orchestrations?
That's a really good question. So I didn't cover that. We have debated that internally. I didn't cover it in this deck here. So the question's around the sort of how many containers per VM, right? The default assumption would be many containers per VM, like more than one. But once you have a technology like Fargo, which allows you to fork and share all memory with the parent VM, that means that VM can be extraordinarily lightweight in terms of its OS memory usage and so forth. And so really all that VM is just the extra app memory usage, whatever app I/O and CPU it uses. And so, yeah, and that, like, once we have Fargo implemented, yes, you could go to a one-to-one model where you want one container per VM. So this is still something we're exploring. We're not going to mandate any way of doing it. Kubernetes today, they do many-to-one. Pivotal and Cloud Foundry does many-to-one. But as these technologies become available, this is stuff we can build into those third platform management systems to, again, it's your choice, right? If you have a set of containers that are well trusted amongst each other, they're probably fine to run inside of a single VM together. But if you're going to do a more multi-tenant scenario where none of these containers can trust each other, maybe you do want a one-to-one type of mapping. So yeah, so you're spot on. That's definitely an option that we're going to be able to expose once we have Project Fargo. Okay, any more questions? All right, well, we're all up here, so feel free to come up and ask us questions offline. Thank you guys so much.